Hello, I'm Kennedy Simius Changi, and I'm going to show you on how to answer this question. The question itself says that the displacement x meter of a particle moving along a straight line after t seconds is given by the equation x equals to t cubed over 3 minus 3t squared plus 9. Part A, determine the value of t when the particle is momentarily at rest. Roman 2, the values of displacement x meter by the time the particle comes to rest. Part B, determine the value of t when the velocity of the particle is -5 meters per second. C, determine the acceleration of the particle at t equals to 2 seconds. Now, to handle this question, first of all, you need to know the relationship between displacement, acceleration, and velocity. So if you have the equation of displacement and you want to find the equation of velocity, you have to differentiate the equation of displacement. And if you have the equation of velocity and you want to find the equation of acceleration, you have to differentiate the equation of velocity. Apart from that, you have to know that when the particle is momentarily at rest, it means that velocity equals to 0. Let's pay attention. Here we go. Determine the value of t when the particle is momentarily at rest. When the particle is momentarily at rest. When the particle is momentarily at rest. First of all, we have our equation as x equals to t cubed over 3 minus 3t squared plus 9. So to obtain the equation of velocity, we have to differentiate this equation of displacement. We have to differentiate this equation to get the equation of velocity. Let us now differentiate dx over dt, which gives us velocity. So to find velocity is just the derivative of all of these equations. So to differentiate this part, it is like 3 multiplied by t, 3, then we less the power by 1 over 3 minus the derivative of this part also, it is 2. You take the power, multiply by 3t, and then you less the power by 1. The derivative of a constant is always 0. That is why there is no derivative of this. So you have to leave it like that. So let us work out this one and see what we shall get. So this one cancel with this. We shall have t square here, and here we shall have 6t as the equation of velocity. So at rest, velocity equals to 0. Velocity equals to 0. Let us now find time when v equals to 0. So 0 equals to t square minus 6t. So to find the value of t, because t is the common factor here, we have to factor out 1t. So we have t minus 6 equals to 0, which is our velocity at rest. So we equate each and every factor to 0. So that means t equals to 0, or t minus 6 equals to 0. So to find the value of t, that is t equals to 6. So at rest, when velocity equals to 0, time is 0 or 6 seconds. Roman 2. Determine the value of displacement x meter by the time the particle comes to rest. So at rest, t equals to 0 or t equals to 6 seconds. Now let us now find displacement when t equals to 0 and when t equals to 6 seconds. So the equation of displacement is x equals to 3 t cubed over 3 minus 3 t square plus 9. So let us now substitute t with 0, that is 0 cubed over 3 minus 3 into 0 square plus 9. If you work out, you will find that x equals to 9 meter. Also, let us find the value of displacement when t equals to 6 seconds. So we have the equation as t cubed over 3 minus 3t square plus 9. Let us now substitute t with 6, that is 6 cubed over 3 minus 3 into 3 into 6 square plus 9. So if you work out 6 cubed over 3, this is 72 minus 3 into 6 square, this is 108 plus 9. So if you work out, you will get negative 27 meters. So at rest, when t equals to 0, displacement equals to 9 meters. And when time equals to 6 seconds, displacement is negative 27 meters. Negative 27 meters. Part B of the question. Determine the values of t when the velocity of the particle is negative 5 meters per second. When velocity, when v equals to negative 5 meters per second. So we have the equation of velocity as t square minus 6 t. So we have the value of v as -5. So -5 equals to t square minus 6t. 6t. So let us bring this -5 on this side so that it makes quadratic equation as t square minus 6t plus 5 equals to 0. Equals to 0. To solve this, let's use quadratic formula, which says if we want to find the value of t equals to -b plus or minus square root of b square minus 4ac over 2a over 2a. So the value of a is 1, the value of b is -6, and the value of c is 5. So t equals to, because of this negative times negative equals to positive, so here we shall have 6 plus or minus square root of b square, that is -6 square, that is 36, minus 4 times the value of a, which is 1, times c, which is 5, that is 20, over 2 times the value of a, which is 1, and that is 2. That is 2. So t equals to 6 plus or minus 36 minus 20, that is 16. So the square root of 16, it is 4. 4 divided by 2. So the first value of t, it is 6 plus 4 divided by 2, which means t equals to 5, or t equals to 6 minus 4 divided by 2, and this gives us t as 1. So those are the value of t when velocity is -5. When velocity is -5, time equals to 5 seconds or 1 second. Part C, determine the acceleration of the particle at t equals to 2 seconds. Determine the acceleration of the particle at t equals to 2 seconds. So when t equals to 2 seconds, so to obtain the equation of acceleration, we have to differentiate velocity. So that means dv over dt gives us acceleration. So the equation of velocity is t square minus 6t. So let us now find acceleration. So to differentiate derivative of t square, it is 2t minus derivative of 6t, it is 6. So this is the equation of acceleration. Now let us find acceleration itself when t equals to 2. So acceleration equals to 2 into 2 minus 6. This is 4 minus 6. This gives us a -2 meters per second square. meters per second square. That is the SI unit of acceleration.